Okay, today we are learning about solving equations with variables on both sides. So just building on what we did in the previous lesson with multi-step equations. So the first thing that we're going to do is we are going to distribute or combine like terms, just like we did in the previous lesson. The next thing that we want to do, and this is kind of the newest or the new part, is that we want to move our variables to the same side. And just like when we move stuff from one side to the other, we'll do that by adding or subtracting. The rest, the third, fourth, and fifth steps are all the same as what we did before. So we'll just keep it on with that process. So first example that we have here, I've got x's on both sides. So what I want to do is look at my first step, distribute or combine like terms. Don't have any parentheses to distribute or any like terms to combine that are on the same side of the equal sign. So I'm going to then go to get my variables on the same side. So for this one, I'm going to add the 2x to the left-hand side. So when I do that, I get 9x plus 19 is equal to 55. Then I can subtract the 19 to the other side. Get 9x is equals 36. Oops. And then divide both sides by 9. So I get x is equal to 4. Again, I can always take this and plug it into both sides of my equation, so I can grab the 4. And I can plug it in for both of my x's. And so when I do that, I have 7 times 4 plus 19 is equal to negative 2 times 4 plus 55. And so when I plug that into my calculator on both sides, get a 47 on this side and a 47 on the other side. Again, same thing on both sides, so I know that I did it right. With the next two problems, it's the same two problems, but I wanted to do it two different ways. So with first way, I want to get my variables over to the same side, so I can subtract the 9y over to the other side. When I do that, I get 80 is equal to negative 3y. And then I can divide both sides by negative 3. So when I do that in my calculator, I go 80 divided by negative 3. Gives me negative 26.6 repeating. If you ever get a repeating decimal, we can always just keep it as a fraction. So in your graphing calculator, you can hit math and enter twice, and it'll turn it into an improper fraction, which leaves it as just negative 80 over 3. So if you ever have to put something like that into a Schoology quiz, just put it in as an improper fraction. The other way to do this is if you didn't want to move the 9y, you could move the 6y, which most of the time we usually move the one that's smaller, but we just need to be careful. So if I subtract the 6y over to the other side, what ends up happening is I get 80 plus 3y is equal to, and I always have to have an equal sign if I start with one. So on the other side, I have to have a number, which in this case is going to end up being a 0. From there, I could subtract the 80 to the other side and get 3y is equal to negative 80 and divide both sides by 3. So again, I get y is equal to, you can just leave it as negative 80 over 3, or negative 26.6 repeating, negative 26 and 2/3. Okay. Down at the bottom, again, another couple problems, pretty similar. So with this first one, I can add the 3x over to the other side. Get 9x plus 22 is equal to 31. Subtract the 22 to the other side. So I get 9x is equal to Whoops. It gives me 9. And I get divide both sides by 9, and I get x is equal to 1. Bottom right-hand corner, again, kind of similar to the one right above it. I can add the 12w to the other side. When I do that, I get 64 is equal to 18w, and then I can divide both sides by 18. So when I do that, I get w is equal to 3.5 repeating. Again, math and enter twice on my calculator reduces it down to 32 over 9. They're both the same thing. And there we go. Okay. Go ahead and flip over to the back. There we go, that looks better. So this one, I'm going to have some combining like terms and some distributing. So I can distribute on the left-hand side my 4, and on the right-hand side I can distribute a negative 2. So when I do that, I get 4 minus 4x plus 3x is equal to negative 2x minus 2. On the left-hand side, I've got like terms that I can combine, so I can combine my x's together. So I get 4 minus 1x is equal to negative 2x minus 2. Again, it doesn't matter which x you move on which side. You can either add the 1x from the left-hand side over to the right-hand side, or you can add the 2x from the right-hand side over to the left-hand side. So I'm going to add the 2x from the right to the left. So when I do that, I get 4 plus 1x is equal to negative 2. And then I can, you don't have to put the 1 in front of the x, you can just put the x. So then I can subtract the 4 to the other side and get x is equal to negative 6. The top right example, again, it's going to be one where I am distributing a negative 1. So make sure we understand that if you put a number in front of it, or you're just distributing the negative sign, whichever way you want to think about it. So I get 2r minus 5 plus r is equal to 13 plus 2r. Can combine my like terms, which gives me 3r minus 5 is equal to 13 plus 2r. Get my r's over to the same side so I can subtract the 2r from the right to the left side and get r minus 5 is equal to 13, and then add the 5 to the other side. Get r is equal to 18. There we go. The last thing is just 2 cases where I'll get either infinite solution or no solution for my answer. So again, approaching it the same way. If I were to distribute the 3 on the left-hand side, I get 3x plus 6 is equal to 3x plus 6. You should be able to see that they're the same on both sides of the equation, but just to make sure, because sometimes we make mistakes with this where it doesn't actually end up canceling out. If I get my x's over to the other side, I can subtract them over. I should see that I get my x's to cancel out on the left side and my x's to cancel out on the right side. So I get 6 is equal to 6. Again, something should be kind of weird that you don't have any x's left. Here you get it's 0x on both sides of those equations. And so what happens is you get, this is either always true or never true. So 6 is equal to 6. That is always true. And what always true means is that I have infinite solutions, which means any number I plug in for x, it will always be true. Same with the one on the right-hand side where, again, I want to get my x's over to the same side, so I'm going to subtract the x from one side to the other. So I should just get 2 is equal to 4. Again, the x's disappear on both sides, and so 2 is equal to 4. That is never true. That's not true. 2 is not the same as 4, and so this would be no solution. You can type no sol. That's never true. There will, for no possible x can I plug it in where I'll actually get something that gives me the same thing on both sides of my equation. So in the bottom of the notes, if your variables cancel out, we'll have infinite solution or no solution. So if the final result is always true or true always, it can be called an identity, or we can call it infinite solutions, just like the example that I have here. 6 is equal to 6 is always true, and so that means that it's going to be infinite solutions. If the final result after my variables cancel out is never true, that means I have no solution. And again, 6 is equal to 0, that is never true, and so that means that I have no solution. And that's it.